Welcome back. With the block class created, we can now link those blocks together to create the actual blockchain structure. So the blockchain is going to have a few fundamental concepts to it. First, it's a chain that is an array of blocks. The first block in this array is the default Genesis block. It should also support the ability to add a block to the chain. Based on some input, it should be able to create a new block and then add it to the end of its own chain. Finally, the new block that is created will be based on the last block that came before it. So a new block will be based on the block that is currently at the end of the chain. So with that, let's create this new blockchain class in our project. So head back to your project, and then we're going to start with a new blockchain.test.js file per our test-driven development approach. So we're going to write that test first. To begin, we're going to require both our eventual blockchain class and the block itself. So let's require this blockchain class, which should be from a local blockchain file. We'll also require the block class, which is going to be used within the context of the blockchain. So that already exists. Now we can describe an overall block of tests for this blockchain class. So the overall description is blockchain. We have our usual callback function as the second parameter to describe. And first up, we're going to make a blockchain instance that is the result of making a new blockchain class instance. So we have our blockchain class at the top, and then this blockchain local instance is lowercase and is the result of making a new blockchain object. First up, as the initial test, this should contain a chain array instance. So that is the first test. We want it to have a chain array. So let's expect that if we look at the blockchain.chain actual value and instance of array, that this should be true. So remember that for true and false expectations with the Boolean, we use the to-be function. Secondly, the blockchain should start with the Genesis block. So let's add that test. So that's one of the properties of the blockchain, that it starts with the Genesis block. We have our callback as usual, and we want to look at the first item in the blockchain.chain. So we'll say blockchain.chain, and the item at index 0 should be equal, and here's where the block class comes in. This should be equal to the block.genesis function itself, or rather the result of the block.genesis static function. The next thing that we wanted the blockchain to have is the ability to add a block. So let's have a test that checks that it can add a new block to the chain successfully. For this test, let's say, that it adds a new block to the chain. Here's our callback. And when we add a block, this needs to consist of some data. So let's make a local new data constant. This can be anything, so how about foo bar? And we'll call blockchain.addBlock. And then our input to this is going to have a data key and new data. So this function that we're creating is going to be called addBlock. And this will do the job of adding a block to the blockchain's chain array. Notice that we're inputting an object, and that object has a key of data, and the value for that is new data. Now, the reason why an object is useful in this case is because we're making this function called addBlock, and the input to that would normally be a block object. So we're representing that normal block input, since we're adding a block, through an object that consists of certain fields that you'd find in a block itself. So in this case, we have the data, which is why an object is a useful structure for the input to the addBlock function. This will become even more clear when we add the addBlock function itself in code. So now finally, as the result of this it function, let's look at the actual value. So that actual recent block in the chain. We want to find the most recent block, which is the last block in the chain. So it should be at blockchain.chain.length -1. So overall, this is going to give us that last block. We're accessing the item at the last position in a chain within the blockchain.chain array. And we want to look at its data field, and we'll expect this to equal our new data actual value, or rather our expected value of this new data variable. All right, great. So that completes a group of tests for this blockchain. It should contain a chain array, it should start with the Genesis block, and it should have the ability to add a new block to the chain. Now, if you already have a test running in the background, it should have picked up these new tests. Otherwise, fire npm run test at the root of the project. Now, first up, it can't find the blockchain module. So let's go ahead and add a blockchain.test, or rather a blockchain.js file. We want to create a blockchain class. So let's create a class of blockchain. And right now, blockchain is not a constructor because we haven't exported this class yet. So call module.exports equals blockchain as the last line of the file. And now we get our actual tests that we've written are failing. So cool, we've made the actual blockchain class available. So our first test is that it needs to contain a chain array instance. We can solve this by making a constructor and giving every instance of this blockchain a chain array with this.chain equals an empty array. So this should get past the first test, and indeed we have a new test at the top of the file to pass. Next, we want this to start with the Genesis block. So at the top of the file, let's make sure that we can access that static Genesis function by requiring the block class from the block file. And then as the very first item in this chain array, we'll call block.genesis, so that way it starts with the Genesis block. And as we do so, now all we have to do is pass that add block test. Very cool. Let's make the add block function. This should take in an object as its argument, which consists of a data field, which kind of matches the shape of a block itself. A block has a data field, therefore the incoming object to the add block function is going to look like a block. It's going to be an object with a data field as well. All right, so now we need to implement the add block function logic. And how are we going to do this? Well, recall that we have that mine block function within the block. We can call that static mine block function as long as we give it a last block to reference as well as some data. So let's make a new block constant that is the result of calling mine block. This also takes in an object that needs a last block as well as some data. But what is the last block in this context? Well, it's whatever is at the end of the local chain. So let's call this.chain and find the last item with this.chain.length -1 overall. So this should give it the last block as well as the data. And once that is constructed, well, in order for the chain to have it, we should push it to the end of the chain. So we'll call this.chain.push, and then we're going to push in the new block into the chain. And as we save it, well, the test suite is green and all clear. All right, pretty awesome stuff. That covers a basic blockchain implementation. We have a chain that starts with the Genesis block, as well as a generic add block method to add new blocks storing data to the chain that also has links with last hash references between each block. Very cool. Now, there's quite a handful of more fundamental concepts left to cover, but this covers the basic structure of the blockchain. So moving on, we need to add a way which we can validate blockchains itself. This is crucial because eventually we're going to implement blockchain replacement, but we only want to replace the blockchain chain with valid chain arrays. So let's discuss that in more detail next, the concept of chain validation and chain replacement.